Yeah, good evening, guys. My name is 𝐓𝐵𝐻𝐵𝐻. I have a total of 21 years of work ex in the IT industry. I'll tell you what is going on in that industry. So there's a bubble which actually bursted around 5 years back. And in the traditional time, traditional means I'm talking about 8 years, 10 years back, people used to work majorly on Java, in C programming, C++, .NET. But there are two programming languages. One is called R and another is called Python. R and Python changed the world altogether in the last 5 years. Why they changed the world? Because there are two main reasons. One is because they are very powerful programming languages in terms of data wrangling. Data wrangling means data joining, concatenating, merging, filtering, outlier detection, statistical overview. Any kind of insights that you want to see in your data can be done through R and Python with a very less number of lines of code. Using Python, we just need to write 30% of the lines of code that you used to write in C++ or Java. Now, in today's world, companies are moving towards an open source environment where they don't want to incur the cost on the procurement of software. So if you remember, if you might have worked on SAS programming, SAS is a very powerful data warehousing programming language. And it was a market leader for 10 years. From 2001 to 2010, SAS was primarily occupied by the major industry big players. And all the companies used to have the license of SAS programming. And it was a very powerful tool for data analytics. But the license of SAS was very costly. In 2009, I still remember it costed around 3 lakh rupees per desktop. And for the enterprise, you can think of millions of dollars. They just need to give to procure the software. But Python changed this whole history, and R also changed this whole history. I'll talk about that as well, along with SQL, and why Python and R I'm talking because of the word data science. So let's move on with the slide. I'll go with the slides first, and then I'll share my experiences of different areas. So we're going to work on what is data science, why SQL is needed for data science, what is SQL, some basics of SQL, and I'll show you some commands of SQL that we need to write. I'll tell you the roadmap which is going to be covered. So first is we are going to learn what is Python. Introduction to Python incorporates some basic data structures in Python like list, tuple, dictionary, sets. Some basic data structures like data types in Python. What are the basic indentation rule in Python coding? What are the different types of variables we can create? How to write on the conditional logic using an if loop, while loop, for loop. Then we are going to work on sequences and file operations. Sequences means any containers like list, tuples, and dictionaries. They are the containers which can contain the huge amount of data. Like you can understand with the term arrays, in other programming languages, they are called arrays where you can store some data into it. Similarly, we have list, tuples, and dictionaries in Python where you can store some data. And we are going to work on file operations like basic file handling, opening a file, reading a file, filtering the contents from the files, and the file operations. Then we are going to take a deep dive in functions. Functions are nothing but a reusable code. We are going to talk about different types of function, arbitrary functions, lambda functions, object-oriented programming concepts like abstraction, inheritance, polymorphism, exceptions and error handling, how to trap the error. There's a block in Python called try, except, else, and finally. So we are going to discuss on how to trap the exceptions so that end user will feel that, okay, the software is robust. Then we are going to work on NumPy, Pandas, and Matplotlib. These are the three very important libraries in Python, which actually made Python really popular. NumPy is a library for numerical analysis. Suppose you want to do any kind of a statistical and mathematical operation. Suppose you want to find the p-value, z-score, IQR for outlier detection. You want to find out kurtosis. You want to find out standard deviation, covariance, variance, correlation map, confusion matrix. So all these things can be done through NumPy. Pandas is a library for data analytics. Suppose you have a data in an Excel sheet, or you have a data in a CSV file, or you have a data in a SQL database. You can fetch the data from that repository and get it into Pandas data frame. And Pandas data frame has got more than 500 plus functions to wrangle the data. Wrangling means merging, joining, concatenating, filtering, subsetting, any kind of operations on the data. Matplotlib is a library for data visualization. Suppose you want to plot a bar chart, histogram, line plot, scatter plot, different types of graphs. If you want to plot, you can write down The very simple lines of code, in few lines of code, you can get the graph. That is done through matplotlib. Then we are going to talk about data manipulation. Data manipulation means once you have a raw data and you want to find the insights into it, you want to plot some graphs, you want to find the statistical inference, you want to find out some deep analysis about correlation between variables, variance within that particular column, whether outliers are there in the data or not, whether the variance within the columns are there or not. So any kind of a statistical and mathematical expressions that you want to put it into the data and find the insights into it, you can use through combination of these libraries, pandas, numpy, and matplotlib. So when we use all these three libraries, we can wrangle the data and visualize the data in a easier manner. Then comes machine learning with Python. What is machine learning? You might have seen in YouTube and LinkedIn and on the other social media websites, artificial intelligence, machine learning, postgraduate program in data science. So what is machine learning? Let me explain you what is machine learning in a very layman terms. Suppose you want to explain what is machine learning to a 6th standard boy who do not know much about computers. In simple terms, machine learning is predictive analytics. When we want to predict future based on historical data, we want to do machine learning, or we are doing machine learning. When you're predicting future based on historical data, suppose I give you last 20 years data of humidity, rainfall, temperature, and crop yield. And if I ask you what is the crop yield in March 2023, then what you'll do, you'll use this historical data, find out the relationship between independent and dependent variables using statistical formulas, and you create some kind of equation and say that crop yield is equal to 1.2 times of rainfall plus 2.3 times of temperature minus 1.6 times of humidity plus some constant. You create some equation to map these independent and dependent variables and use this equation in future to predict something. And that is called as machine learning. We are not in the era where machines have got intelligence. So all these movies, I, Robot or Terminator, are just a science fiction. We are not in the era where machines can think and take decisions. We as a programmers are using some statistical algorithms like linear regression, logistic regression, decision trees, random forest, naive-bayes classifier. There are so many of them. We use these algorithms to find the hidden insights in the data and mathematically equate some equation and use this equation for predicting things. So the end user feels like that machine has got intelligence. But we as a programmers are writing down the piece of code using these algorithms and finding the insights in the data and predicting future. And what are the applications of this machine learning? Applications are Uber cab or Ola cab. When you book a cab, you come to know cab is going to reach you in 10 minutes. We are predicting. The system is predicting that the cab is going to reach you in 10 minutes, depending on weather conditions, depending on road traffic and all those things. Go to Amazon and buy a laptop. Amazon recommends you, why don't you buy a laptop bag as well? So this is what machine is predicting, that what next item you can buy, and it is promoting their sales. There is no human intervention. And machine learning is a subset of artificial intelligence. Artificial intelligence is anything which is mimicking human behavior. So anything you are trying to mimic like a human, it is coming under the umbrella of artificial intelligence. And machine learning is a subset of artificial intelligence. Subset means it's a part of artificial intelligence. Deep learning is a subset of machine learning. There's another term called deep learning. Deep learning is a subset of machine learning where we're talking about images when the data is multidimensional, like 3-dimensional, like RGB values in a pixel. So when we have a 3-dimensional data, machine learning algorithm fails. Then we have to rely on deep learning. There are different libraries for deep learning like Keras, TensorFlow in Python. And deep learning is primarily focusing on computer vision or handwritten text identification, text conversion, German to English, text translation, image colorization, coloring a parrot from a grayscale to a colored image. So all these things comes under the umbrella of deep learning. So machine learning is a subset of artificial intelligence. Deep learning is a subset of machine learning. And machine learning primarily deals with predictive analytics. Association rules and recommendation engines, as I was talking about, it's also a part of machine learning, recommendation engines. we are using an algorithm called a priori, APRORI, which is used by Amazon to recommend the products to the end customer. So this is again an important library. Then comes reinforcement learning. So machine learning is again divided into three parts: supervised machine learning, unsupervised machine learning, and reinforcement learning. Supervised machine learning is one where we know the column headings in the data. When we know what is dependent variable, what is independent variable, what we want to predict, and what all variables we need to predict, that is called supervised machine learning. Unsupervised machine learning means you have numbers and you don't know what these numbers are. You want to cluster it in different clusters. So all the clustering algorithms like K-means clustering, C-means clustering, agglomerative clustering comes under unsupervised. Reinforcement learning is learning with experience, slow and gradual learning. For example, manless car. So scientists used to give some 100 images to the car on a daily basis, and car takes some decision. These decisions may be right or may be wrong, and keep on giving 100 images on the daily basis. And for the wrong decisions, we give some penalty and some policy that next time this should not happen, and keep on supplying images. And time has come where machine knows millions of images, what action to take. So that is called as a reinforcement learning. It's an area of research. All the innovation-based companies who are into innovation, they use reinforcement learning, like chatbots. You might have seen the chatbots become smarter and smarter. Gaming companies, where games become smarter and smarter day by day. So that is called as the reinforcement learning. Then comes the time series analysis. So we have stock data, like if you want to predict the stock price, what is going to the stock price tomorrow based on the historical stock prices, then we are using a time series analysis. And then model selection and boosting. So when we do all this machine learning task and we found the accuracy is not coming good, we try to improve the accuracy by using XGBoost and ADA-boost algorithms. So in order to get a better accuracy, we use different algorithms to improve the accuracy. That is called as boosting algorithms. And then we have a final project. Now, what is data science? Data science is a process deriving useful insights from the data in order to solve real-world problems. So imagine I have given you the KYC details of a customer who are there with Amazon, like age, gender, location, address, last purchase histories, and I've given you millions of customers' data to you, and you want to get some insights into it, and you want to figure it out. Laptop is bought by what age group? What is the age group of the people who are primarily focusing towards purchase of laptop? Or in which season, what products were sold most? So all the real-time problems can be solved through data by finding the hidden insights. And data science is just a process of finding that hidden insights. Do you know that we are generating more than 2.5 quintillion bytes of data each day? So that's a huge amount of data we are generating on a daily basis worldwide. This pace of data generation is a reason behind popularity of high-end technologies like data science, artificial intelligence, machine learning, and so on. So it is impossible for a human to find the hidden traces in this much amount of data. So that is the reason we are using a lot of softwares and tools and techniques like DevOps, like we are using Kubernetes, we are using big data like Hadoop and Spark environment to process this amount of data. And we want some programming languages to find the predictions on this data. And that is the reason Python and R became popular. So data science is a holistic view where it incorporates data acquisition, data gathering, data mining, then filtering, then doing some hidden insights, data visualization, getting some predictions. So data science is a broader term which encapsulates everything. Now, why SQL is needed for data science? Data science involves extracting, processing, analyzing tons of data. At present, what we need are the tools that can be used to store and manage this vast amount of data. So SQL is nothing but a relational database like Oracle, like MySQL. It's a relational database having data stored in a form of an Excel sheet, like an Excel sheet, in a form of a tables, where rows are called tuples, column headings are called attributes, and we store the data in a form of a tabular format. And then we can use the column headings to filter the data, or we can use some different commands in SQL to process this data. Data wrangling commands are there in SQL, and data manipulation commands are there. So data science involves extraction of the data, processing of the data, and analyzing it. And for that, SQL is used. SQL can be used to store, access, extract massive amounts of data in order to carry out whole data science process smoothly. So as I told you, we need to fetch the data from a repository first, then we need to process it. Then we want to find some hidden insights into it. Then we want to predict it. And for all this, we need a good tool where we can store the data and do some data wrangling queries. And for that, we use SQL. Of course, for prediction, we use programming languages like Python, but we need some data to predict. A raw data on the top of which we're predicting, that raw data is supplied by SQL. What is SQL? SQL is structured query language, is a querying language aimed to manage relational databases. So relational databases means you can perform some joins like inner join, outer join, left join, right join, based on some primary key, foreign key, secondary keys. So there are a lot of terminologies in SQL again, like first normal form, second normal form, Boyce Codd normal form. We have a lot of commands in SQL. I'll show you the cheat sheets in SQL that we can use to write on different commands. Okay, so what is SQL? SQL is all about querying, inserting the data into the tables, updating those tables, deleting the data from those tables, extracting the data from those tables. So RDBM is a data management tool where data is stored into different tables. So we have columns and rows. We have different structures in which we can store the data, and relations are established among those data variables using primary keys. So in one table, it is called as a primary key. In another table, it is called as a foreign key. For example, you have one data which is in a form of a employee data. So let's say I create one data set. So let's say I have one table, table 1 or employee table, having column headings as employee ID and age and salary. So let's say I have employee ID 101, age is 22, salary is 20,000, 102, age is 23, salary is 23,000, and 103, age is 41 and salary is 44,000. And I have another table called KYC table. And in this, we have employee ID, name, and gender. 101, name is Amit, gender is male. 102, name is Sumit, gender is male. 104, Sunita, and gender is female. So let's say I have two tables. This is one table and this is another table. And I want to perform some inner join. So inner join will do what? Inner join will give common records. So I'll join with employee ID. So I'll get an employee ID. What is common in both of them? We have 101 and 102. And we have name and gender, salary, age, and salaries. And we have name and gender. So this is going to be the output for inner join, where common records from both the tables will be fetched and we get a holistic view. Then comes the left join. Left join will do what? It will take complete first table and matching from second. So we'll get everything from here. And we have matching here as Amit and we'll get here, and this is going to be NA. NA means missing value. In Python terminology, it is called NaN, or in R terminology, it is called NA. NA means missing value. Similarly, for the right join, we get all the data from the right and the matching from the left. And similarly, we full outer join. So these queries can be written like select star from table 1, select these columns from table 1 and table 2, where age is equal to something. So we can use select queries to filter the things, and we can write down the join queries to join the different tables. So these all primarily operations we perform on any SQL database, like querying, inserting, updating, deleting, and extracting. SQL programming can be used to perform multiple actions on such data. So we can use PL/SQL for writing down the procedures in SQL. And SQL itself is a big ocean where we can do a lot of things in terms of database management. So why to use MySQL? Because it's an open source. MySQL is a relational database. It is open source. It can support huge amount of data sets. It can support multiple programming interfaces. You can connect MySQL with Python. You can connect with .NET. You can connect with Java. So any programming language can connect with MySQL using connection string and fetch the data from a repository. And we can very well customize MySQL as per our needs. So there are different data types in SQL, like numeric types, where we have integer, small int, float, real, double, precision, and decimal. We have character data types. We have varchars. We have globs. We can store the data which are bits, bit varying. We can store Boolean data, true, false. We can store date and time formats. We can store timestamp and interval. So it can store any kind of a data having different meanings. Now, if we talk about basics of SQL, we can use create database name and we can use that name to use the database. So create database command is used to create the database and use is to activate the database. Similarly, we have commands to create a table, create table name, and different variables in the table, which various columns in the table. We can write insert into that table some values, insert into table some values, and we can give values in the same order of the columns. We can insert the data. Similarly, we can select star from the table. It is going to select all the rows. If I give select column A, column B from table, it will select only for those columns. We can write on the update query, update table name, set variable name, where some condition. So if you want to update the age, where name is Amit, so it will search all the names where Amit is there and change the age. So based on certain condition, we can change the value of certain field. Similarly, we can delete the data from a table, delete from table where some condition. So based on certain condition, we can delete the whole tuple, whole row. Similarly, we can drop the table. Drop is going to delete the table from the memory. Drop table name is going to completely delete the table. Thank you for your time, guys. Bye-bye and take care.